I've got to say right off the bat, that's really an honor to work with your company. I've been an aeronautical engineer for about 15 years now, and I've been lucky enough to see airplanes built all over the world. And you know, when I first came to your shop, I don't know how many months ago, 6-8 months ago. I mean, I haven't seen quality like this since I was in Switzerland at the Pilatus factory. And I think you guys should all be commended for, holding up the standard of quality you have here. It's amazing. I mean, it's just like going to the Pilatus factory. So I just wanted to tell you guys that it's just great to work with you. And I think you're doing some really awesome work up here. So the PMA system. So as Eric said, you guys are going to get into building FAA PMA approved parts. And of course, right now, you guys build a whole lot of airplane parts from a whole lot of drawings. And you're the only company I've been to who is fabricating entire aircraft as owner-produced parts, or almost entire aircraft as owner-produced parts. PMA is a little different than owner-produced parts. Owner-produced parts are fabricated and installed under Part 43 only. PMA parts are approved under Part 21. Part 21 is type certificates, STCs, TSOs, PMA, right, all these acronyms. I'm going to use a lot of acronyms today, so if anybody's got a question on acronym, let me know. I tend to use way too many acronyms. So you're going to transition or part of your business from fabricating to production, and that's an important distinction for the FAA because the fabrication rules are different than the production rules. It's a different portion of the regulations. The basis of a PMA system, the thing that separates it from fabrication under Part 43, the thing that brings it into Part 21 is two things, and it's really the first two upper left-hand blocks, is an FAA-approved quality system and FAA-approved design data. So right now, you guys use FAA-approved design data to do fabrication under Part 43. Now, you're going to use FAA-approved design data to do production under Part 21. And that's an important distinction with the FAA, is this notion of fabrication versus production, airworthiness and manufacturing. Those are an FAA-approved quality system and the design data that describes that approved design is just the fundamental basis for the PMA. The FAA says, yes, your manual's good enough. Let me back up. We prepared a manual for your company. Brad's polished the manual. Eric's worked on it. There's a manual. It's pretty straightforward. It'll be available for everybody to read. The manual describes it describes in detail the basic processes that we'll talk about today. It's been submitted to the FAA. Right now, you guys are working on your first PMA data package. So within approved manufacturing, you have the manufacturing portion of it, how you control your quality as you're building, and you have the design portion of it. Is the design acceptable? Is the design airworthy? So we're going to work with the manufacturing district office in Minneapolis to get the manual approved, and then we're working with the certification office in Chicago to get your first chunk of design data approved, which for you guys is going to be the springs, P-51 springs. I'm a designated engineering representative for structures and power plant, a DER, which means I can approve certain types of descriptive data drawings in support of a design approval. So what's going to happen is the feds are going to sign off that your manual meets the requirements of Part 21, Subpart K, which is PMA parts, and then the certification branch of the FAA is going to sign off on your first chunk of design data. They're going to say, yes, your design data is okay. At that point, you'll be able to use the processes in the manual to produce a PMA part that'll go out the door with an FAA PMA stamp. Whereas right now, when you guys put a part out the door, it's a fabricated component, not a manufactured component again. And the chief difference in marking on PMA parts and non-PMA parts is the wording FAA PMA. Right, so whenever you see the wording FAA PMA on a part, you know that came from a manufacturing process, not a fabrication process. And so you're only going to use that FAA PMA marking on parts that are run through your quality system, not parts that are run through your fabrication system. There's kind of a few basic chunks of the quality system. You can kind of see the dash lines up here, but the top one is engineering and quality management. All right, that's your manual, and that's your data. The second one is data control. How is the design data controlled? Who controls it? How do you know it's current? The third one, is purchasing, buying stuff, buying materials, buying parts, buying processes, buying vendors to do things for you. Is it a forging? Is it a finish operation, right? All the purchasing that's involved in getting stuff. Then there's the manufacturing, where you're executing the procedures called out on the work order to build the thing, to end up with a completed thing. And then there's the inspection process, where you're reviewing the design of whatever that thing is against your approved data, and you're ensuring that it conforms to the approved data or goes through one of these other processes we'll talk about. At that point, the part can be marked after it's inspected, marked PMA, and shipped. And I put sales in here as well. You know, sales comes in two portions. One is to take an order to begin with, and then one at the end is after it's stocked, when they actually move something out the door. And I'll try and talk about these in the context of these different chunks of the PMA system, because generally in an organization, you've got folks who do data control, which in this case is going to be Brad and I and whoever else Brad assigns. You've got folks who do purchasing generally, finding parts, finding materials, finding vendors, locate, who can do a forging, who can do this, complete this finish operation you need. And then manufacturing, right? The people who actually, bending, pounding, cutting, grinding, like the meat of the process. And then you have the inspection. Now, I don't know that we're going to have an inspection department per se. It sounds like after yesterday that a lot of folks who are executing the manufacturing process may be involved in the inspection process as well, but they're two kind of distinctly different things. In one, you're manufacturing a component in accordance with the approved design data. In the second, in the inspection, you're checking every aspect of that part with your calibrated tooling to make sure that it really does conform at the end before you put a PMA stamp on it. So those are kind of the basic kind of departments of an FAA quality system. Okay, so we've got our FAA approved manual. We've got our controlled and approved design data. So let's say for now we're going to use these springs as an example. We've got, 18-inch springs that we're going to be submitting for design approval. Okay, so now the sales department or person or whoever it is takes an order for springs. Customer calls up, says, hey, I see on your website you have FAA PMA approved springs for the Mustang. I'd like 100 of them, please. You say, okay, that's great. We'd like to sell you 100. The first thing you're going to do after that is go find the design data, that block that says assemble design data. So all the design data, all the FAA approved design data for PMA manufacturing at this time is going to live in this office, and it'll be controlled by Brad and also by me. I'm only going to be up here when I need to. Generally, Brad and I will coordinate on what data goes in and out of the file. But all of the official FAA data will live in this file. There's also going to be a digital copy available on your system. You guys are really good about having digital data available. When you're using that digital data, you want to verify that you have the current information. And you verify that you have the current information by checking the master drawing list. And so for every PMA that you guys get, in this case there'll be a group of 18 springs, there's going to be a drawing list on top of that drawing package that lists out each of those drawings by number, date, and revision. And so you're going to pull up drawing X off of your server for spring part number Y. It's going to have a revision and date. You're going to check that revision and date against the master drawing list. Then you might ask, well, how do I know that the master drawing list is correct? So on the front of the cabinet here, hard copy, will be an index that shows you for every master drawing list you have what the current date and revision level is on the MDL. That way you can pull a print off the computer. You can say I've got drawing X, it's a no change revision, it's dated 6 March 15. Okay, I'm going to go to my master drawing list. Yep, that drawing is at that date and rev. I know that's current. You're going to check your top of your master drawing list is going to have a date and revision as well. The master drawing list might be, Rev A dated whatever. You're going to check that the index here says that Rev A is the current master drawing list for that approval. The other thing you're going to look for attached to the design data may be something called a drawing change notice form. So there'll be either, if it's in digital, it'll be page 2 or the last page of the PDF. If it's hard copy in the file here, there'll be a physical drawing change notice form stapled to the print itself. A drawing change notice is a drawing revision that's issued without actually up-revving the drawing. So you've got the drawing for a spring, it's at Rev A. Brad calls me up and says, hey, we got a diameter wrong on this spring, and I'll talk about this more in a second. We can issue a drawing change notice immediately without revising the drawing. There's a process for that. Brad and I will generally take care of that process of issuing the drawing change notice, and then you, as the fabricator who's pulling the data, know that you're going to be working with that Rev A drawing plus any changes that are attached on that sheet. At some point, those changes get wrapped in to a drawing revision, and we'll talk about that. So that's how you verify that you have current design data, and it's really, current design data is a continuous thing with the FAA. When we do have an audit here, that's generally one of the things I'll always look at, is to make sure that the information that you're using on a work order calls out a drawing that's current and on file. Again, that's what really separates approved manufacturing from fabrication, is this notion of design data control. Okay, so now, tell me if I'm going too fast, and I'm just going to kind of run through this and then we'll do questions. So now, you've got an order, you've got your drawing. Now, the purchaser or purchasing department has got to get materials. And so what's going to happen is the purchaser is going to issue a PO. Okay, we have a form for that, it's in the manual. The purchase order will be issued. The things that you purchased are going to show up. And on that purchase order is going to be a drawing date and revision level if it's a fabricated component. On the purchase order will be a specification if it's a material. So let's say you're going to order a bunch of 2024 T3. The purchase order is going to say 2024 T3 per AMS QQ-A 250/4, right? Or it's going to be, steel per AISI 4130. There'll be some specification on the purchase order itself, or there'll be a drawing reference on the purchase order itself. Okay, so now the parts show up, FedEx, they go to purchasing inspection. A purchasing inspector or a work order or a regular inspector, one or the other, who will be assigned in the manual as a person authorized to do receiving inspections, will then execute that receiving inspection. When that is done, you're doing a couple things there. You're going to verify the vendor sent a certificate of conformance, which is required. So the vendor has to write on a napkin, I, Jim, from company X, say that I built part number A from drawing number A dated whatever, right? It can be written on a napkin, it could be a 20-page document with legal disclaimers, but they have to tell you in writing that they have built that thing or provided that stuff to your specification. If it's a material, right, you're going to look for a mill cert, material cert that'll come with the material, tracing it back to the mill with the lot number. You're going to use controlled and calibrated tools to execute an inspection after that. So let's say that it's not a raw material, but it's a cylinder barrel. And you had a honing operation done on the inside of the cylinder barrel. So you're going to pull some calibrated tools, all the approved tools right now anyway, right, for inspection, for all PMA parts to be located in this room. This room for now is going to have all the stuff for PMA operations only. And it's important that we don't mix up, again, fabrication and production. And so the FAA wants physical segregation in a facility when you're doing multiple things. So when you get a repair station eventually, you can't intermingle your repair station stuff with your production stuff either, right? So all of your calibrated tools will be in this room. they're all controlled on a list. They're all calibrated on a schedule, and that's outlined in the manual. It tells you, how often to calibrate each instrument. So now you're going to take your calibrated caliper or your bore gauge, whatever it may be, out of the tool room here. You're going to walk over to your barrel. You're going to measure the dimensions on the drawing. If there was a material or a heat treat operation provided with that part, you're going to check to make sure there's certificate of conformance and there's a mill cert. Point there is you got to use calibrated tools to do PMA inspections. So the caliper you have in your toolbox isn't good enough. Generally, it's good if you write down what tool you use when you use it, and all the tools are numbered and serialized. The point is that the instruments you have in your toolbox aren't what you want to use for a PMA inspection. Now, of course, we all know that your caliper works fine, right? And when the part shows up, you can swag it and say, yep, that looks pretty good. Let me get that off to an official inspection. Or say you pull your caliper out and 2 inches is 2.5 inches, and obviously it's not right. Well, there's no reason to go get a calibrated tool to find that out. So, when the purchase PO inspection is done, there's one of 4 things that are going to happen. In the manual, there's a number of tags that you guys are going to start to use for tracking your parts and your materials, specifically as those parts and materials are used for production, not fabrication. And at the end of that purchasing inspection, there's one of 4 things can happen. And the -3 tag is a reject. It's a red tag. Material and/or parts do not conform to design data. There's no rework or anything like that that's going to be done. It's just not the right stuff. It's just wrong. We can't fix it. That's going to get a red tag, and that material is going to go into a segregated area. You can have red tagged rejected materials all over the shop because you can use them to make tooling. You can use them to make a template. You can use rejected materials for stuff. You just can't use it for approved FAA production. So the other thing that can happen is that the purchase order was for a part. So let's say in this case we've got one of your vendors is shipping springs in. Brad does the inspection on the springs. Turns out that they meet material spec, they meet dimensions, the workmanship was of high quality. Those springs are acceptable. That's a completed part. That part can get a -12 completed part tag concurrent with the inspection executed in the work order. So when you get a finished part from a vendor, you skip the manufacturing block, right? You go right from purchased to inspected to PMA stamp. When you get a material in on a purchase, a stack of 2024 T3 sheet, as it were, there's 2 things you can do. You can put a -27 tag on it, which is accepted material tag. So it's 2024 T3, it met the right specification, I've got the mill cert for it, I've attached that mill cert to the purchase order, I've signed and stamped the purchase order, and I've given that to Brad to file in the purchase order book. All purchase orders are filed for 10 years, all work orders are filed for 10 years. So all these records are kept for a long time. The 10-year requirement is technically only for critical or life-limited parts, for other parts, the records requirement is 3 to 5 years, but we're not going to delineate between critical and non-critical parts with the records keeping. You put all the files in a box, and the box just keeps getting more full for paper. You can put the -27, which is a good material tag. You got a stack of material, meets a spec, and you're going to push it out on the floor. It's going to be used for production. It's going to be over in a bin somewhere, but all approved material is going to have a -27 tag. Or it doesn't conform, and you're going to use a -22 hold material tag, which in our case right now is green. And that -22 tag is a signal to say, look, this doesn't conform to the specification that was on the purchase order. I ordered 2024 T3, I got 2024 O. Well, that's not what we need. So when a materials, for example, we get a spring in that's short 1 winding, and it doesn't meet the deflection and strength requirement, right? That gets a whole material tag. All of the held materials, that kind of puts the part in kind of in limbo, and we get to decide what to do with it from that point. After the whole material tag is placed on, there's different things you can do. You can run it through what we would call a material review board, where Brad and Eric and I get together, we look at the non-conformance, and we decide if that's going to be acceptable for the part's fit, form, and function. If it is, the material review board provides us a way to put a non-conforming part out the door marked PMA. And that's kind of a powerful thing, and we don't use it that often, but we do have that option. The second one is to do a drawing change. We got a recommendation form for changing drawings that'll be available to everybody. You're going to look at that and say, oh, this drawing's wrong. This part actually should be like this. The vendor did it correctly. In that case, we're going to execute a drawing change recommendation form. You're going to give that to Brad, and then we're going to issue a drawing change notice. That drawing change notice will be stapled to the approved data. Now you can redo your inspection, right, with that changed design data that allows you to conform that part. And the other thing you can do with the whole material tag is the MRB board, Eric and Brad and I, can decide, well, that thing's short, the spring is short of winding, and it doesn't meet the force versus deflection requirement. There's no way to rework it. There's no way to fix it. There's no way to make this thing go. It gets chucked, thrown away. Or there's a way to rework it with the MRB. So let's say that the MRB says, yes, the drawing says painted green, but the part's painted yellow. Okay, well, just go paint the part green, and it'll conform to the drawing. So the MRB can issue a rework instruction to make that part conform to the approved design data. Okay. So those are the different things you can do when the part gets a whole material tag. But the real thing to remember there is that raw material comes in the door or parts, and it doesn't meet the design data. You either throw it in the garbage right away, or the scrap bin, or whatever we want to call the rejected material bin or something, or you put a whole material tag on it. But what you don't do is put an accepted material or an accepted part tag on it, because that part doesn't conform to the design data. So now we've got our raw materials, we've got our parts. We're going to execute our manufacturing operation, okay? So you're going to use the approved data, the approved materials, and the work order that was issued. Back up on the sales block up top there, you see order for parts placed, the PMA work order opened. The work order is what signals the system to do something. So that's the demand you're putting in the system. I got an order for 100 springs. I'm going to write a work order for 100 springs and give that to the production manager. We're going to make 100 springs. So now you're going to use the work order, the approved data, and the approved parts and materials to execute the manufacturing operation. You put stuff together, build stuff. That's the fun part, right? This is it's the fun block. Okay, now you're halfway through building it and you realize that our drawing is wrong. Or maybe there was a mistake on a North American drawing. It's possible, you know. But we find out in the middle here that our drawing needs to be updated, or that if we build it to the drawing, it's not actually going to turn out the way it needs to. In that case, again, you can use the drawing change recommendation form. You're going to fill it out, drawing, date, revision, change dimension, 1/8 inch radius to 1/4, please. You're going to give that to Brad. Brad's going to work with the CAD guys, with me, to issue a drawing change notice or issue a drawing revision, give you back the drawing change notice with the changed data, and then you can proceed to have an approved design that's updated with the correct drawings and has been manufactured to those specifications. The point there is that the drawing change recommendation form is the way for the person building the part to say, hey, this isn't right. You know, this needs to be changed, right? That's kind of the feedback loop. So now you built it. You built it with your approved materials. As you're building it on the work order, you're recording every lot of material you use. Okay, so you go pull, you're going to build a rib. It's 2024-0. You're going to go to the shelf where the approved material is. You're going to pull 2024-0 that was bought under purchase order 123. You're going to record purchase order 123 on your work order. Same with hardware. You're going to pull a bunch of nuts, bolts, and screws for your assembly. you're going to record, I pulled those nuts, bolts, and screws from lots 5, 6, and 7. Every time you pull approved material for use on a work order, you have to be able to trace that material back to where it came from. The reason is if you have a service problem, let's say we put out a bunch of wing ribs and they all crack. It's a safety issue. The FAA issues an AD against those wing ribs now. They'll come to us and say, okay, where was this material used? Identify all the parts that were built with this lot of 2024-0. And we have to be able to go back into the system and say, yes, work orders 1, 2, 7, and 20 used this lot of material. Now we can identify in part where those parts went and try and track them down. But the point is that you have to record the materials that you use on the work order as you're doing the construction. That's a pretty important step. We're done building it. We've filled out the work order completely. We've got all of our operations were on there, all of our materials were on there. We've recorded the purchase order number for everything that we've used that went into that assembly. Now we give it to the inspection group. Now that might be just Brad for now, but at some point there's going to be more people doing inspections that'll have they'll be authorized in the manual. People will get an inspection stamp. When you're doing the inspection, you're going to use that stamp and sign the work order when you're done to indicate the part's approved. And within the quality manual, there'll be a roster of people who are authorized to do that and an example of each person's stamp. You're going to use your, basically, it's inspect, tag, and mark. That's the basic things. You're going to use your calibrated tools again to do any required inspections. Is it when you put the assembly together, we just did a caravan nose gear torque link. Well, it turns out there's a machining operation required for the assembly that you have to check when the assembly's done. So you wouldn't have done that at the purchase order level. You do that at the fabricated level, right? So you're going to look at your assembly, your part, take your calibrated caliper, your micrometer, whatever it may be, measure it up, and make sure it's good to go. If it's a first run of a production lot, so we're going to make 20 ribs. It's the first time we've made 20 ribs. Generally, the first part that comes off that production line, you're going to run a first article inspection on that. You're going to measure all the dimensions in their entirety, every dimension on the print, to make sure that one part is good before you run the other 19. Now, if it's the 100th time that you built that rib, no need for a first article. The work order will call out if a first article is needed or not. Whoever generates a work order, which right now will probably be Brad, will indicate if first article inspection is needed. The other time you use a first article inspection is for an R&D part, okay? So research and development parts that we're going to do new PMAs for will be marked in the upper right-hand corner, R&D, right on the work order. You'll know that that's a research and development work order, not an FAA-approved manufacturing work order. R&D work orders are used to trace prototypes as they travel through the system, so that after you're done and you hand the whole package to the FAA and they issue the design approval, you can wrap those work orders into your system, execute the final inspections, stamp those prototype parts PMA, and actually ship them out the door. If you don't track prototype parts with work orders, you don't have a mechanism to sell them when you're done, and you end up with prototype parts that make nice paperweights. Except for ribs, not going to make a nice paperweight. That's the block there, lower left hand is, execute calibration, or execute construction, execute inspection, pardon me, with your calibrated tools. After that inspection's done, one of three things is going to happen. Again, you could issue a -3 rejected part. We inspected the assembly. This thing's wrong. It's not reworkable. It's red tagged, goes in the red tag parts area. The other option, -22, is a hold material. Okay, it turned out we put the assembly together with all our approved parts and all of our approved materials, but it doesn't match the print. Okay, put a hold material tag on it. That's going to be the signal for the material review board right, to go evaluate that component, to evaluate that assembly. Is the fit, form, and function the same? Does it still meet the airworthiness requirements for the original approval or not? And you get into the MRB process. And what you want to do most often, of course, is a -12 tag, which is a good part tag. That's an accepted part tag. Once that tag goes on there, it says FAA PMA, and that's now an approved part. And then the final thing is to sign and stamp the work order. Okay, so now you've executed the whole inspection. You're going to take your inspector stamp, you're going to stamp the bottom of the work order, you're going to sign it, and you're going to mark the part, or ensure it's already marked, with FAA PMA, AirCorps Aviation, I guess will be the trademark, or a symbol trademark, and the part number. The other thing you're going to do at the very end of this step, so now the inspection's done, your part marking is finished, right? It's almost done. The last thing you need to do is check the PMA 6-column supplement. And that's, in essence, that's the approval that the MIDO, the manufacturing division of the FAA, will issue that says that AirCorps part number X is the same as North American part number Y for this model airplane in accordance with this design data. And so you list all your parts out on this 6-column supplement, and the manager of the manufacturing office signs that thing, and that's what says that you are authorized to fabricate approved components. And what you're looking for at that last step is to make dead sure that the part number that you've marked on that part, like physically on the part, matches what's in that 6-column supplement, to verify that it is an FAA approved component. It's kind of your last step, because if you don't do that and you send a part out the door marked PMA that's not PMA'd, the feds do not like that at all. And you could be subject to a suspected unapproved parts investigation. In the worst case for that, Brad and Kyle and Eric could go to jail and face civil and criminal penalties for, putting unapproved parts out the door that led to an airplane crash. There's 20 people dead in the field. We'll probably go to jail for that. So that's a critical step right at the end to make sure that that part is approved. And I say that because at Airforms here a couple of years ago, we just went through a situation where we were doing that. We were confusing owner-produced parts and PMA'd parts, and it was not clear to manufacturing staff what was what. Now we had a big corrective action. We had a self-disclosure with the FAA. It took us 2 years to dig us out of the hole, but we're out of it now. But we were able, by self-disclosing, to avoid civil penalties. And there were no accidents. That's what generally triggers the FAA to get pretty stiff. So that's kind of the last step. You make sure that your part is listed on the 6-column supplement. All those 6-column supplements will be available on the server, and they'll also, in the top drawer in here, will be what we call the FAA airworthiness data file. And in that airworthiness data file is going to be all the letters that went back and forth to the FAA, the engineering reports, any 8110-3 forms that were signed to approve the engineering data, results of any conformity inspections that were accomplished, a copy of the FAA 6-column letter authorizing you for production. It's kind of like your, it's your airworthiness file for that part. The data in that file shows that the design of that component meets the airworthiness standards in Part 23, in CAR 3, in Aero Bulletin 7A, whatever the appropriate certification basis is for the article. And then at that point, that part's now stamped, tagged, and recorded. It can be put on the shelf and ready for shipping. And right now, this shelf up here is going to have PMA components only. One of the challenges you guys are going to have is separating your fabrication work from your manufacturing work. And one of the ways that we're going to sell the FAA on that is physical separation. Everything in this room is PMA stuff. Everything out here is not. We may have some parts bins in the back, some material bins that might also be part of the PMA as well. But what the pitch to the feds right now is physical separation. That shelf will only have PMA components for now. I mean, obviously, when you build a tip tank or something, it's not going to fit in the shelf. We'll have to do something different, you know. Or when you build 50 header tanks at the rate you're going, and we're going to have to find a place for those too. We're going to have that discussion with the FAA when they're here for an audit, which is kind of the next step in this process, is that we're going to schedule an audit with the FAA. They're going to send an inspector or two up here. Brad and Eric and I are going to walk them around the shop. We're going to have a big dog and pony show. You know, we're going to show them all this awesome stuff you guys are doing. We're going to talk about the PMA system, and hopefully they're happy when they leave and they'll approve the manual. Hopefully that happens in the next month or so. So, and we'll get to questions here in a second. Recommended reading. Okay, 14 CFR Part 21, Subpart K. That starts at 21.301, I believe it is. Subpart K is manufacturing, FAA approved manufacturing, the requirements for an FAA approved PMA system. The quality manual is going to be a must read 100% for everybody. Everybody's going to need to read that quality manual. You need to understand what's in there, and you need to understand the intent of why it's in there. That's really kind of the important thing here. I mean, knowing the procedures in the manual is great, but I think once you have an understanding of what's the intention of FAA approved production, okay, it's controlled design data, it's controlled materials, it's documented inspections, right? It's a system to make sure that the right parts get out the door, right? Once you understand that intent, I think the manual becomes more useful. You know, otherwise it's kind of 39 pages of, you know, sleep. And then 14 CFR section 21.3. It's not in subpart K, and I wanted to point that out. That's compulsory and mandatory failure, malfunction, and defect reporting. So that's things like, we got a call from a customer yesterday, we built them an exhaust system, it fell apart on the airplane, they had a fire. Okay, the approval holder for that exhaust system is required to call the FAA within 24 hours, either the ACO or the certification office or the manufacturing office or the FSDO, somebody at the FAA, and tell them that there's been a safety issue with a part that went out the door. 21.3 lists all kinds of other failures. You know, any failure leading to an engine out situation needs to be reported. Anything that results in a fire needs to be reported. Anything that results in loss of control needs to be reported. And so there's these kind of big heavy hitter safety items that we're required to report within 24 hours. Generally, Brad, for the most part, is going to make that reporting. If he's not around, Eric and I would probably do it. But I just want everybody to be aware of those requirements in 21.3. That's a big one for the feds. Again, you know, the premise of the approved quality system is approved design data and an approved manual. The manual is required to be controlled. All the copies of the manual that Brad's going to distribute to inspectors, to purchasers, all those manual copies will be controlled, and there's an index in the master manual that says, you know, Brad's got the master manual, Kyle's got manual number 1, Eric's got manual number 2, et cetera, et cetera. And you can't just go like photocopy one and pass it around the shop. The copies of that book are controlled, and that's done so that when we revise the manual, that all the books get revised the same way every time. And so we'll have a digital version available that anybody can read at any time, and it'll be kept current. But the official hard copy version, when it's given to you, or when it's put in a location, say it's a library copy or it's a purchasing copy, you know, they'll be controlled. So that's an important thing. What you don't want to have is an audit where the feds come by and there's a manual, you know, that says draft or something sitting on your workbench. They don't like that. You know, it's got to have a control number on it.
Do you have to get, how do you handle if you have a digital copy of the manual and somebody saves it to their desktop and that changes? So now, you know, you can't really do that.
You can't really do that. Yeah, I mean, you could mark it for reference only.
How are other manufacturing shops managing their manufactured parts versus fabricated parts? are they following kind of one standardized system regardless of if it's a fabricated part versus a manufactured part?
It's a good question, and I've seen it done both ways. The last, well, more one than the other. Typically, it's where there's a repair station and a PMA manufacturing facility in the same place. Their records are totally separate and different. Repair station work order, not the same as a PMA work order. It's different form, requires different actions, and you end up with two completely segregated sets of records in that case. Because the FSDO is not concerned at all about your PMA manufacturing. On the other hand, the MIDO, the manufacturing, doesn't care about your repair station.
Sure.
And so in those cases, I've seen them just be segregated completely. Now, at a shop where you don't have a repair station, I think that there's more of an opportunity to intermingle those two things together. And we talked about this a little bit yesterday. It doesn't make sense to not do a receiving inspection on half the material you get in the shop because you might have to use it for a PMA at some point. Technically,
Yeah,
absolutely.
okay.
They can ask anybody they want, any question they want. Generally, what'll happen is they have a handler, right? One or two or three people handle them around the shop and will help them understand what's going on so they don't have to like walk up to a random person and be like, where's your work order? If you do not have traceability for anything, hardware, material, parts, if that thing is not traceable back to something, you can't use it for approved production. It's got to be traceable back to something. You can do the testing, and so if you don't have a certificate of conformance from, you know, the manufacturer in 1939 when that thing was built, obviously you're not going to have it. Just like Eric said, you could take a couple parts, you know that it's a steel nut plate, it's got a fiber lock on it. You know, you're going to do a chemical analysis of the material. Maybe you do a quick hardness, a micro hardness check on it, and you generate that conformity data. You know, generally on new PMA assemblies, you know, you're always going to call out a modern material specification. So you're not going to see 24 ST, you know, on an AirCorps PMA print. The FAA doesn't generally like that. You're going to see, you know, an MS number for a nut plate, or it's going to be a special nut plate. It's going to have an AirCorps specification for it, right? Generally, you're going to use current specifications for new design data. Hey, thanks, guys.
Thanks.
I really appreciate the visit. You guys do awesome work up here, so.